Welcome to the educational video on the typical use cases for the Cascade boiler installation with Bosch Condens GC7000WP. In this video, we take a look at the integration of a cascade of Bosch GC7000WP condensing boilers into a heating system already equipped with a building management system. When integrating with an existing building management system, BMS, one of the possible solutions is the use of the MC400 module. This module facilitates the seamless integration of a cascade setup of Bosch condensing boilers. It controls the heat output or temperature demand of the GC7000WP cascade by converting the 0 to 10 volt output signal from the BMS. This solution requires no programming or complex setup, offering a straightforward plug-and-play experience. The MC400 module is specifically designed for managing cascade systems in combination with EMS boilers. It features high-voltage terminals for pumps and mixing valves, along with a 230-volt input on-off and a 230-volt mains supply. The MC400 also includes low-voltage terminals with an EMS bus connection and 0 to 10-volt terminals, as well as terminals for temperature sensors, remote controls, and external switches. To properly install the system, the first boiler must be connected to the bus 1 terminal and the second boiler to the bus 2 terminal on the low-voltage terminals of the MC400 module. Furthermore, the low loss header sensor, labeled T0, has to be connected to the appropriate terminal of the MC400. Attention! The T0 sensor is not included in the scope of delivery of the MC400 module and must be ordered additionally. An external building management system must be connected to the 0 to 10 volt terminal of MC400 module. It is very important to ensure the correct polarity when connecting the BMS to the 0 to 10 volt terminal. The connections are as follows. 1 is ground, 2 is 0 to 10 volt input for heat demand from the building management system, and 3 is 0 to 10 volt output, optional, for feedback. As mentioned above, the first GC7000WP boiler must be connected to the bus 1 terminal, the second boiler to the bus 2 terminal, and the strategy sensor to the terminal T0 of the MC400 Cascade module. The connection for the boiler pump PC0 is located in the pump connection box at the bottom of the GC7000WP. For the safe operation of the Bosch boiler cascade with cascaded flue arrangement, it is essential to utilize CO detector set. This set includes an automatic boiler cutoff module, DBCO, and a CO detector, DCO. The potential free contact of DBCO automatic boiler cutoff has to be connected to the I3 terminal of the MC400 Cascade module, as shown in the provided diagram. The DBCO is also autonomously connected to the power supply, AC. In case of a critical CO level, the cascade will be shut down. The cascades will not be completely off power. They will restart only when the critical CO level has been underreached. Therefore, the CO detector must be connected to the MC400 Cascade module. The MC400 module enables users to select a control strategy through the position of the address coding switch. When the boiler cascade is operated by a 0 to 10 volt request from the BMS, 4 cascade control strategies can be set, corresponding to address code switch positions 6, 7, 8, and 9. We will examine these strategies in detail. Output control strategy. For the output control strategy, there is a linear relationship between the 0 to 10 volt signal and the required power as a percentage of the maximum system output. There is no internal temperature control in the MC400. The cascade output is defined via the 0 to 10 volt interface, and thus also the modulation behavior. Sensor T0 is only used to monitor the maximum flow temperature at the low loss header. A minimum voltage, 1 volt, is required to start the cascade in order to prevent irregular boiler starts from standby state. The cascade is switched off when a voltage is below 0.5 volt. The voltage range between 0 and 0.5 volt, corresponding to 5% of the power range of the entire cascade, cannot be used for modulation. For example, in a cascade with a total power of 200 kilowatts, the lowest possible operating power is 10 kilowatts, equal 5%, even if a single unit could modulate lower. The output control strategy can be configured by selecting position 6 or 7. Position 6 is an external 0 to 10 volt power control with serial standard Cascade. And position 7 is an external 0 to 10 volt output control with serial optimized Cascade. And what is the difference between serial standard and serial optimized Cascade strategy? Serial standard Cascade. There is no change of boiler sequence. The connected heat generators are switched on and off according to the wiring. The boiler at bus 1 terminal starts first, then the boiler at bus 2 terminal follows. When deactivating, this sequence is reversed. Serial optimized Cascade. The aim of this control strategy is to operate the heat generators with equivalent burner runtime. The connected boilers are switched on and off according to the burner runtime. The boiler with the shortest burner runtime is switched on first, and the one with the longest runtime is switched on last. The burner runtime is compared every 24 hours, and the sequence is re-established. Flow temperature control strategy. There is a direct correlation between the 0 to 10 volt signal and the desired flow temperature. The 0 to 10 volt temperature setting of the BMS is converted in the MC400 by an internal PI controller into a power setting for the individual heat generators. A minimum voltage of 1.5 volt is required to switch on the Cascade to prevent irregular starting of boilers from standby state. The Cascade is switched off if the voltage is lower than 1.0 volt. The voltage range between 0 and 1 volt cannot be used. MC400 Address 8 enables external 0 to 10 volt flow temperature control with serial standard Cascade. Address 9 supports external 0 to 10 volt flow temperature control with serial optimized Cascade. The following sequence is essential for the installation and initial commissioning of the MC400 module. Before setting up the MC400, ensure that all heat sources and bus nodes are disconnected from power at every connection point. In accordance with the installation manual, install the module on a wall using a mounting rail or within an assembly. Then, connect the boilers, T0 sensor, CO detector set, and the BMS to the MC400 without a power supply. Please note, if the maximum cable length of the bus connection between all bus nodes is exceeded, or if there is a ring structure in the bus system, the system cannot be commissioned. Once all connections are properly established, then supply power to the MC400, the designated boilers, and the CO sensor. Afterwards, switch on the boilers. Finally, set the coding switch to the desired control strategy. The MC400 module will detect the connected devices. Depending on the number of devices, this can take up to 5 minutes. During this time, the controller will not respond to heating commands. As soon as the first device is detected, the MC400 activates the power supply on the system bus. When the address coding switch is correctly positioned and communication through the bus system is successfully established, the operating indicator lights up green continuously. If the coding switch is not positioned correctly, the operating indicator initially does not light up and then turns red. For comprehensive guidance on assembly, electrical connections, and commissioning, please refer to the MC400 module installation manual. In this video, we explored the integration of a cascade of Bosch GC 7000 WP condensing boilers with an existing building management system by utilizing the MC400 module. The communication between the BMS and the MC400 module operates through a 0 to 10 volt interface. There are 4 control strategies available for this setup. For the safe operation of the boiler cascade with cascaded flue arrangement, it is essential to connect a CO detector to the MC400 module. Additionally, it is important to follow the sequence for installation, electrical connections, and commissioning of the MC400 module. In the next video, we examine a heating and hot water system using a cascade of GC 7000 WP and a controller which enables internet connection, remote monitoring, and diagnostics complying with Part L building regulations.